In this video, you will learn about sample spaces. Now, what is a sample space? What it is it's a set of all possible outcomes. So for example, if you flipped a coin, you have the possible outcomes of a heads or a tails. So that would be your sample space. It's the set of all the possible outcomes. Or if you roll a die, which is singular for dice, by the way, if you roll a six-sided die, the possibilities would be a 1, a 2, a 3, 4, 5, or 6. So the sample space of rolling a die would be any of those numbers, 1 through 6. Now what happens if you were to do multiple things? So for example, if you took the coin and you flip it 3 times, or you have 3 different coins and you flip it each 1 time. Well, what we can do is we can create what we call a tree diagram to figure out all the possible outcomes that could happen. So for one coin, as we mentioned, we have heads or tails. So the sample space for flipping one coin would be heads or tails, and you can write it with these little braces around it. All right, so there's the notation. And by the way, if you are writing this freehand, it's going to look something like this. All right, so that's your notation for the sample space of one coin. And the H is for heads and the T is for tails. So what we have is 2 possible outcomes, heads or tails. Now if we put a second coin in here, okay, for the heads, the second coin could be a heads or tails, but if it's tails for the first coin, we could also have heads or tails for the second coin. So what we have are different possibilities. We have heads with heads or heads with tails. All right, so we have heads, heads, you see that here, heads with tails right here, or it could be a tail followed by a head, so that's T then H, tail then head, or tail followed by tail, so that'd be the TT right here, tail, tail. So what we have are 4 possible outcomes when you flip 2 different coins. Now if we continue this pattern, and we do this again for a third coin, for the heads right here, for this heads, we could have for the third coin a heads or tails. If it was tails for the second coin, it could also be heads or tails for the third coin. And then down here, for these options, for this head, okay, it could be heads or tails for the third coin. And then if it was a tail right here, it could be heads or tails for the third coin as well. So looking at this tree diagram, we have different possibilities. Okay, so looking here, we could have heads, 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 or it could be heads, heads, tails. So we have those, heads, 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 or it could be head, head, tail, or it could be head, tail, head, or it could be a head, tail, then a tail. So it could be those options. And then down here we have the same kind of idea. It could be a tail followed by a head, followed by another head. So we have tails, heads, heads. Or it could be a tail followed by a head, followed by a tail. Or it could be tail, tail, head. Or it could be a tail, tail, and then a tail. So you list all the possibilities out, and we have it typed up right here. And the total number of outcomes would be 8. So we have found the sample space for 1, 2, or 3 coins. And if we wanted to, we can continue this pattern, and we can do it for 4 coins, 5 coins, and etc. Now what this does for us is we can use the sample space to find the probability of something happening. So for example, we might be asked, when flipping a coin 3 times, what is the probability of getting all heads? All right, now remember, when you find the probability, we take the favorable outcomes, so what we want to happen, divide by the total outcomes. So when you flip 3 coins, or a coin 3 times, the total outcomes we found here are 8. So the total would be 8 for the denominator. Now the favorable, what we want to happen is we want all heads. So when you look here at the sample space for 3 coins, how many of these options have all heads? Well, there's only one way to make that happen. All right, so the favorable outcomes would be 1. So the probability of getting all heads would be 1 over 8. And if you wanted to, you can write this as a percent. So you convert to a decimal to get 0.125. Then as a percent, that would be 12.5%. Let's try another example. Here we have, when flipping a coin 3 times, what is the probability of getting at least 2 tails? So again, we're flipping the coin 3 times. So when we figure out the probability, we take the favorable over the total outcomes. And the total outcomes for 3 coins we found is 8. That is your sample space. All right, so we have 8 for that. Now, getting at least 2 tails. So at least 2 tails. Looking here at the sample space we wrote out, here we see 2 tails. Here is 2 tails, 2 tails, and then here is 3 tails, which would be included because when it says at least 2 tails, it could be 2 or 3. So what we have are 1, 2, 3, 4 possibilities, 4 things that we want to happen. So that is your favorable. So we take 4 over 8, which can reduce. That gives you 1 over 2. So the probability of getting at least 2 tails is 1 over 2, which as a percent would be 0.5 or 50%. All right, so that's how we can use the sample space to find the probability. Now, another thing we can do is notice here when we are determining the total number of outcomes, okay, we could list it out as we did here, right? So we just kind of go through with a tree diagram to figure out that total number of outcomes. But there's a short way that we could do this, and that is by using what we call the fundamental counting principle. And what this is it's used to find the number of outcomes mathematically. So instead of listing out every single option, we can just use math to find the total outcomes. So using the coin example, okay, when we say a coin is flipped 3 times and we're trying to determine how many possible outcomes are there, okay, we already know the answer is going to be 8, right? We have already shown that in the last slide, but we want to be able to do this mathematically. So what you do is you put here coin 1, coin 2, coin 3, because we're flipping a coin 3 times. And what you put here is the total possibilities for each event. So when you flip a coin, there's 2 possibilities, heads or tails. For the second coin, there's also 2 possibilities, could be heads or tails. For the third coin, we still have heads or tails. So what we have would be 2, 2, and 2. And what we can do is we can multiply these together. 2 times 2 times 2, and that gives you 8. All right, so we have calculated mathematically that the total outcomes for flipping a coin 3 times would be 8. So notice this is going to be much quicker than listing out every single possible option, especially when you start putting in 4 coins, 5 coins, or let's say we roll a die multiple times. It's going to speed up the process by a lot, doing it this way. Now let's try a couple more examples. Okay, so example 2, we are flipping a coin 4 times. And the question is, how many possible outcomes are there? So it's the same idea. We have coin 1 has 2 options. It could be heads or tails. Coin 2 could be heads or tails. Coin 3 could be heads or tails. And then coin 4 as well could be heads or tails. So if you multiply the 2's together, 2 times 2 times 2 times 2, that gives you 16 total possible outcomes. Let's take a look at one more example. And here, with example 3, we are looking at a restaurant. So Jared wants to make a sandwich and has 5 types of bread, 4 types of meat, and 3 types of cheese to choose from. And the question is, how many different types of sandwiches can he make using all 3 ingredients? So when you do this, we do it the same way we did for the coin, where we have 3 different things. We have bread, we have meat, and we have cheese. So we have 5 options for bread, we have 4 options for meat, and 3 options for cheese. And using the fundamental counting principle, you multiply those numbers together. 5 times 4 times 3, that gives you 60. So the total possible types of sandwiches that he can make using all 3 ingredients would be 60. So in this lesson, we've learned how to find the sample space. We've learned how to find the probability of an event using the sample space. And we've also learned how to use a fundamental counting principle to determine the total number of outcomes. And that concludes our lesson for today. We will see you next time.